Okay, hi everybody. Welcome to lesson 12, pretty much the last lesson of the Addie unit. Hey, we've been learning about Addie and finding out kind of what happened to her. We remember that she got sick from some bacteria. Maybe it came in through a scab that she was picking. That was the community spread MRSA. And then she got really, really sick. And then they put her on the ECMO machine and she picked up another bacteria called Stenotrophomonas. And that was a resistant bacteria and she got even sicker. What we're going to try to do based on some of the computer simulations we've been doing is see if we can kind of summarize, if we can pull it all together and figure out exactly what happened in Addie. Now, to do that, we're going to have a really, really simple model. You have to understand that inside Addie, there are millions and millions of bacteria, and we can't possibly draw all those bacteria. So I'm going to be sticking with really small numbers to make a point, not that the numbers are accurate at all. So let's go ahead and start over on this side over here. We're going to talk about, give me just a second. I want a drawing here. I forgot my stylus. And so I have some funny, it's going to be, some of my drawings are going to be a little bit funny. So let's imagine right here, I'm going to draw, this is my bacteria. I want you to draw with me. So hopefully you can draw a little bit better than I'm drawing. So we got some Stenotrophomonas that come in from the hospital itself. So I'm going to actually type transferred from outside environment, hospital. So she picks up this Stenotrophomonas and it gets inside of her body. So notice system 1 here is inside Addie, system 2 is outside the environment. So let's start drawing what the bacteria look like. And again, I said I'm going to keep this really, really simple. So in this circumstance, we're going to draw 4 bacteria. And we're going to say that 75% of the bacteria are harmless, not resistant bacteria. And I'm going to show not resistant bacteria red. So these are the bacteria that the antibiotics can kill. And I'm going to show resistant bacteria in a purple color. And will be consistent throughout the time, the whole time that we're drawing. The resistant ones will be purple. I'm going to put an R so you know that that's resistant. And the red ones are going to be not resistant. So here's my NR. All the ones that are red are not resistant. Okay, so let's also graph that. Let's show what that would look like. So if 75% of them are not resistant, then we're going to make a bar like this to represent the not resistant. And then we're going to make another bar to represent the other 25%, which were the resistant bacteria. So over here it says, how was Addie feeling? And we're going to keep that really simple. Addie was initially feeling, trying to move quickly here. Where did my colors go? There we go. Let's give it a bright green color. So here's Addie. And initially, oops, I didn't draw that very well. I'm trying to show her being happy. Wow, that's a bad drawing. I'm drawing with my finger, you guys, so it's going to be pretty lousy. Okay, so she's feeling good initially. This is at the very beginning of her infection. She has a whopping 4 bacteria inside her body. So she doesn't have, it's not literally 4 bacteria, but you're getting the idea. So she has a small number of bacteria in her body, and initially she's feeling pretty good. However, those bacteria start dividing. Over time, they're all going to divide. So we're going to watch. This is going to go from generation 1, that's what this is, to generation 2. So they're all going to start dividing. So I'm going to draw some arrows. I want you to be drawing the same images on your paper. Yeah, I hope you don't have to use Cami like I'm using because it is hard to do this. So all of these guys, I'm showing them dividing. We learned that they go through the process of binary fission and they make identical copies of themselves about every 20 minutes. That's called exponential growth. And we end up with a lot more. So I'm going to draw. I know it's an ugly picture. You're just going to have to forgive my finger, which is not very good at drawing these. I'm going to draw 6 of the red bacteria, and then I'm going to draw 2 of the purple bacteria, which are the resistant bacteria. So right now we still have way more non-resistant than resistant. But because the bacteria are dividing, that's going to make Addie start to feel cruddy. So I'm going to make Addie start to feel lousy. We have twice as much bacteria in her body right now. And I'm going to go ahead and show the graph. And the graph looks exactly the same. And that's a really important point. Oops. That's something I really want to make sure you understand. When we don't add any antibiotics, there's no change in the population. It's still going to be 75% are going to be not resistant and 25% are going to be resistant. So the graph is exactly the same. However, right now we're going to, because she's feeling bad, we're going to add antibiotics. Again, you should be writing this. I'm hoping that you have the paper copy of this assignment and that you're just handwriting this. So remember that in our simulation, we showed antibiotics as like black dots. And I'm going to see if I can draw some black dots to show my antibiotics. So you could use a pencil or whatever and just show the antibiotics. Maybe I'll draw an arrow so it's really clear that these are the antibiotics, okay? So we're adding antibiotics, and we're going to assume that the antibiotics kill a certain percentage of the bacteria. So give me a second to redraw the bacteria. I'm going to scroll up right now. We're going to redraw these same exact colonies of bacteria, but then we're going to draw an X through some of them to indicate that some of them have died. So here I am drawing the exact same. There's 4 here, 4 red ones. 3 and 4, and then 2 over here. I'm drawing the same ones from from the up here, and then I'm going to draw 2 purple ones. And the antibiotics, let's say that the antibiotics kill 3 of the not resistant ones. So I'm going to draw a black line through them. So it's going to kill 3 of them. So it doesn't kill all of them, but it kills some of the not resistant bacteria. So these guys are goners. And now, of course, they're all going to start dividing again because that's what they do. But before they start dividing, let's go ahead and draw the graph. Now the population has changed a little bit. First of all, Addie is probably feeling a little bit better now. She's had her antibiotics. The number of bacteria now is 1, 2, 3, 4, 5. So she has fewer bacteria in her body. And what's interesting now, though, is that the percentage of them have changed. So let's go ahead and show we have 3/5, 3 out of 5 now are red. So 3/5 is about 60%. So I'm going to make the graph look like this. Okay, and now 2 out of the 5 are resistant. So I'm going to make the resistant be about 40%. So that's, oops, I don't know if I did that very well. I'm going to try that one more time. 40% is a little bit higher than I made it. Okay, so we're starting to see, because we added antibiotics, I want you to compare this graph to this graph. We're starting to see a change in the population because we added antibiotics. Now, time's going to go by and the bacteria are going to start reproducing again because that's what bacteria do. So we're going to show lines, and this is them going through binary fission, of course. Each bacteria is going to divide into 2. And what's interesting is as long as we're not adding any antibiotics, we're not going to see any changes in their population in terms of what percent are resistant and what percent are not resistant. So it's going to be a little bit trickier to draw. We're going to have to start drawing really small now, and this is going to be hard on my hand. So these are still bacteria. I just don't have very much space. Ruh-roh, my doggy is going to start barking in the background. I'm going to pause the video for just a moment while she finishes barking. Okay, well, I paused, but my dog might start barking again. I think there are deer in our backyard. So, okay, I'm going to keep drawing the replicated bacteria. So we've got those. And now this time there are 4, trying to draw them, 4 of the resistant bacteria. Okay, so now again, whoops, let me hide that a little bit. So right here, the population has now increased. We have more bacteria. So Addie's going to start feeling lousy again. So over here, we're going to give her a sad face because she's feeling bad. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She has 10 bacteria inside of her. If my dog starts barking again, I'm just going to try to keep going because she's hard to control. Okay, so we still have 10 bacteria. So let's take a look. We've got 4, 5, 6 out of 10 are 6 out of 10 are the not resistant type, and that's still 60% because we haven't added any more bacteria. I mean, any more antibiotics. And 4 out of the 10 are resistant, so that's 40%. So notice the graph hasn't really changed. At least I'm trying to make it look like it hasn't changed because we haven't added any antibiotics. However, because she's feeling cruddy, we're going to need to add some antibiotics. So we'll do it again. Antibiotics, okay? And we make those, that's how we do our little black dots, right? Where's my black here? So we're going to add some antibiotics here to these bacteria, and we're going to kill a certain percentage of them. Make your little black dots all around, show that these are the antibiotics. Okay, so we're trying to make Addie feel better because she's getting sick again. So we're gonna repeat. I'm gonna draw this image, the same image again. So let me get my red out, and I'm gonna draw 4 reds right next to each other, and then 2 reds over here. So these are the not resistant bacteria. And then I'm gonna draw 4 purples in the middle. These are the resistant ones. And of course, the resistant ones don't get killed by the antibiotics. So the antibiotics are going to kill the red ones. So we're going to draw some X's, and let's go ahead and kill 4 of the resistant bacteria. I mean, not resistant bacteria. It doesn't kill all of them, but it kills many of them. So we're going to kill off 4 of the not resistant bacteria. So I'm going to draw X's through them. I want you to draw this along with me. You should be drawing everything along with me. Okay, so now that really has changed things. So we've given the antibiotics. Addie should be feeling better again. So we're going to show her feeling a little bit better. She's got 1, 2, 3, 4, 5, 6 bacteria in her. So she's starting to feel improved again. However, well, and let's go ahead and graph that. So now the graph is really starting to change. If you notice, we only have 2 not resistant bacteria left. So 2 out of 1, 2, 3, 4, 5, 6 is about 33%. So we're going to need to make a 33% for the not resistant, and that's, I don't know, about here. And then the resistant make up about 66%. So that's, I don't know, somewhere around here. Look at how the graph changed. And everyone, I want to make sure you understand that the resistant are starting to take over because we're using the antibiotics. We're killing off the weak bacteria, they're dying. And so that allows the resistant ones to reproduce. Okay, and speaking of reproduction, that's what we're going to draw. We're going to go through this a couple more times and then we'll be done. So let me show all of these. It's always hard to draw these. Show all of them reproducing. I'm going to make it slide over a little bit. And then there's no more over there. And now I'm going to get the purple for the resistant guys. And we'll show them reproducing. Oh, I didn't do that very well. And 1 and 2. You can draw this better than me, I hope. And down and down we go. Okay, and let's draw a purple one for each one. So each one splits in half. The population is doubling. I don't have enough space. I'm not drawing well. I'm really critical of myself, aren't I? I wish I'd had my stylus. It would have made this so much easier. Okay, I'm going to switch colors and I'm going to draw the not resistant red bacteria. The purple ones, again, were all the resistant. I don't really have enough space for this, do I? Okay, so now what's going on? Well, Addie's going to be feeling cruddy again because the bacteria have just really increased. So we're going to give Addie a sad face here in generation 4. She has 12 bacteria in her body, and that's making her feel cruddy. However, we haven't used any antibiotics yet. So right now, the population is staying exactly the way it did, the same percentages. So 33% for not resistant, and 66% for resistant. And I'm trying to make these graphs look exactly the same. They might not look absolutely the same, but they're supposed to look the same. Okay, because she's feeling lousy, we're going to add antibiotics. You know what we're doing here now. And you're going to go ahead and draw those with some black dots. And we're going to redraw all those 12 bacteria. And let's go ahead and kill off This time we'll kill off 3 of the 4 resistant or not resistant bacteria. So we're going to kill off 3 of the 4 red bacteria. So I'm going to redraw them. Let's see, I need my red color. So I'm going to draw 4 reds. 1, 2, 3, 4. And I'm going to go ahead and draw black X's through 3 of them. Hope I'm doing that right. I am. Just want to make sure I've got a plan. I've got a plan. We're headed somewhere, everybody. Okay, we've got these. So 3 out of the 4 remaining not resistant bacteria are now dead. And let's draw the rest of the resistant. And there are 1, 2, 3, 4, 5, 6, 7, 8 of them. So 8 of the purple circles here. 2, 3, 4. I don't think mine are all going to fit. 5, 6, 7, 8. Okay, they're going to have to start doubling and I won't be able to draw it, but that's okay. Okay, so now we added antibiotics here. Now we've completely changed the population again. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 bacteria inside of Addie. So 9 bacteria. That's actually quite a lot of bacteria. So this time when we added antibiotics, it didn't actually make her feel that good. So Addie's just kind of feeling, meh. In the past, when we added antibiotics, Addie felt better. But now Addie doesn't feel any better or not much better when we add the antibiotics. She still has 9 bacteria in her, which is a lot. The proportion has become more extreme. We have fewer of the not resistant. So 1 out of 9 is not resistant. So that 1 out of 9 is about 11%. So about halfway to 25, about 11% are not resistant. And so that means 89% are resistant. So we're going to need to get that. I didn't draw that very well, but you get the idea. Not quite in somewhere in that ballpark. Okay, so that's our not resistant to resistant group. And now, of course, those bacteria are going to start dividing. And I can't draw all the arrows with my finger. It would make me go crazy. So I'm going to make the red one. I'm going to allow the red one to double. So let's just, I'll show a few of them. Oops, that was the wrong thing. I needed the drawing. And I need that in red. Okay, I'm going to go ahead and show that this is doubling, and then you'll just have to know all the purple are doing that too. So we're going to have 2 reds, and then how many purples? 1, 2, 3, 4, 5, 6, 7, 8 purples. So I need to draw 16 purples. I don't think my finger can draw that much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh my goodness. How do you suppose Addie is feeling right now? Addie is full of bacteria. She feels horrible. She's getting really, really sick. She's got 18 bacteria inside of her. And again, as you know, the proportion didn't shift. So we're at about 11% not resistant and about 89%, see if I can do that well, better this time, 89% are resistant. So in a last ditch effort, the doctors are going to go ahead and give her her last bit of antibiotics. So antibiotics, and you can go ahead and draw the black dots for the antibiotics. So here's our antibiotics that we're putting into Addie, and they're going to kill the last of the bacteria that are not resistant. So we have to draw these one more time. We're going to draw 18 bacteria. This is the last time that we draw them all out. So I'm going to draw 2 reds, these guys right here. And I will tell you that the antibiotics are going to kill them. So the 2 reds are gone. There are no longer any not resistant bacteria. The only bacteria that are surviving are these 16 purple bacteria, and they're all resistant. So 3, 4, 5. I wish I could draw faster than this. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So 16 resistant bacteria. And now what I want you to label over on the side here is antibiotics stop working. So this is bad. The antibiotics no longer do anything for her. Um, Even if we add antibiotics in the environment, nothing's going to happen. It's going to be worthless to have antibiotics now because it is entirely resistant. So now Addie over here, if we draw Addie again, oops, I wanted to draw green. Addie is now so sick that we don't know if Addie's going to survive. We'll show her tongue hanging out. And she has 16 bacteria in her right now, and the antibiotics are no longer functioning. Okay, so we're going to pause there. We're going to pull it all together. It says, why don't antibiotics work like they used to? So we're going to try to draw what might happen. So it says, so this is like a cartoon that we're going to draw. We're pulling all our ideas together. In frames 1 and 2, what would happen if Addie coughed on her hands and touched the light switch in her hospital? So assume her bacteria were at the generation 5 level above. So these bacteria. So while she's sick, she coughs on her hand. So let's go ahead and try drawing a picture of a hand. I'm sure I'm really good at drawing a picture of a hand, especially in this situation where I'm drawing with my finger. What do hands look like? So this is a hand, right? Oh, people, look at how good this drawing is, right? The question is, which of these fingers was supposed to be my thumb? Okay, there's her hand. And let's go ahead and use purple to show that she coughs some resistant bacteria on her hand. Okay, and then she goes and touches the light switch in her room. So I'm going to draw her light switch. This is the light switch, and we'll just make it real simple. So this is the light switch. I'll even label it light switch so that we know what it is. So light switch. There we go. She touches it, and now we learned when we looked at the petri dishes that bacteria from your hand can get transferred onto surfaces and vice versa. So I'm going to go ahead and draw, here, the 2 bacteria that were on her hand. Now they have transferred over to the light switch. So I want you to be able to see that they transferred from one place to the next, okay? So the bacteria on her hand transferred to the light switch. Okay, so then frame 3 says, what would happen if a visitor came by and touched the light switch and then touched her mouth? So imagine it's a friend of Addie's or something like that. So we can draw a face. I'm just going to draw a circle. Is that a face? There we go. Oh, there we go. And let's give it some hair, everybody. What's good hair? There we go. Oh, that is some awesome hair I've got going here. So this is Addie's friend who's got some really fun hair. I shouldn't be using purple. I should use a different color. So hold on. I got to undo that one. Let's give this person pink eyes. Pink eyes. Sorry. Oh, wow. That is quite an eye. And here's the person's mouth. How should I draw this mouth? We'll just draw the mouth as a smiley. So this is a friend, and I'm now going to draw the purple bacteria on the friend's mouth now because the friend touched the light switch, and now the bacteria have transferred to the friend's mouth. So now the friend, it says in frame 4, it says, what if Addie's friend later sneezed on a public bus? So let's do some stuff here. First of all, let's label that this is her friend so we know what that is. And then let's write achoo. She sneezes and blows all of that bacteria all over the place. So let's draw a bus. Let's see. How does a person draw a bus? Can you draw a bus better than me with my one finger? I don't even remember how to draw a bus. How does a person draw a bus? Here we go. I got an idea. Here we go. So this is my old-timey school bus. How about that? So, and there's a tire here. Wow, this is a really great drawing, KJ. There's a wheel here and a wheel here. I made the bus purple, you guys. I didn't mean to make the bus purple. That was dumb because I want you to see that the purple bacteria are now all over the bus. We learned in one of the articles we read that bacteria get onto a bus and then people pick up the bacteria from surfaces. We learned that especially the cloth seats are likely to have bacteria on them, less so the vinyl seats. They don't get as much bacteria. Okay, so then the question here says, how is the bacteria population on the bus different from the bacteria population that Addie may have originally picked up? Well, if you remember, Addie's original bacteria, in our example here, Addie's original bacteria was only 25% resistant in my little example. Now, what it really was in the real story, we don't know. But just in this model, Addie's original bacteria was only 25% resistant. The bacteria on the bus are completely resistant to antibiotics. So the next person that picks them up could be in really, really big trouble. So then it says, how could the use of antibiotics lead to bacteria that is more resistant now than in the past? So we're gonna say some fancy stuff here. This is the longest thing you have to write, and then we're all done. So antibiotics put this is fancy, selection pressure. What's that? On the bacteria. You're like, what's selection pressure? We're going to start talking about evolution, and that's what a selection pressure is. Something that the environment does to a population that forces them to either change or go extinct. So antibiotics, they either have to shift or they're going to all be killed by the antibiotics. So the presence of antibiotics gives some bacteria an advantage over, that's supposed to say advantage, I can spell, advantage over other bacteria. Antibiotics wipe out resistant bacteria. Whoops, nope. Wipe out not resistant. Wipe out not resistant. I'm going to maybe hyphenate that. Not resistant. Or another word would be susceptible. We've used that word a few times. Susceptible bacteria. Antibiotics wipe out not resistant or susceptible bacteria, leaving resistant bacteria behind to, this is important, reproduce. Over time, the proportion of resistant bacteria increases. All right, everybody, that's it. Let me know if you have any questions.